Today, we're diving into the fascinating world of quantum technologies and their potential to revolutionize various industries. It's like we're standing on the brink of a technological renaissance, where quantum physics is reshaping our understanding of science and technology. Imagine a world where computations that would take today's supercomputers millions of years to solve could be done in mere minutes. That's the promise of quantum computing.
Wow, that's mind-blowing. So how exactly is quantum physics making this possible? I mean, how does it differ from the computers we're used to?
Great question. Traditional computers use bits as the smallest unit of data, which can be either 0 or 1. Quantum computers, on the other hand, use quantum bits, or qubits, which can be both 0 and 1 simultaneously, thanks to a phenomenon called superposition. It's like flipping a coin and having it be both heads and tails at the same time.
That's wild. So it's like having a supercharged multitasking ability. But how does that translate into real-world applications?
Exactly, it's like having a supercharged multitasking ability. This capability allows quantum computers to perform complex calculations at unprecedented speeds. For instance, they could revolutionize drug discovery by simulating molecular interactions at the atomic level, which is something classical computers struggle with. Imagine finding new medications for diseases that currently have no effective treatments.
That's incredible. So we're talking about potentially curing diseases faster and more efficiently. But what about other industries? Are there any other areas where quantum technologies are making a splash?
Absolutely. Quantum technologies are making waves in sectors like finance, telecommunications, and energy. In finance, quantum computing can optimize asset allocation and enhance fraud detection by analyzing large datasets for subtle patterns. In telecommunications, quantum communication offers highly secure methods of transmitting information, making eavesdropping nearly impossible.
Secure communication sounds crucial, especially with all the data breaches we hear about. But how does quantum communication actually work?
Quantum communication uses the principles of quantum mechanics to secure data transmission. One promising technology is quantum key distribution, which allows two parties to share encryption keys securely. Any attempt to intercept the key would alter its quantum state, alerting the parties to the breach. It's like having a security system that not only detects intruders, but also prevents them from entering in the first place.
That's like having a digital fortress. So, with all these advancements, are there any challenges that come with developing quantum technologies?
Yes, there are challenges, like error rates and scalability, especially in quantum computing. But the potential benefits far outweigh these hurdles. As research advances, we're likely to see more industries adopting quantum solutions, driving innovation and creating new opportunities. It's an exciting time to be exploring the quantum frontier.
It really is. I can't wait to see how these technologies evolve and impact our lives. Thanks for shedding light on this quantum revolution.
Let's dive into one of the most exciting breakthroughs in quantum computing from NTU Singapore. Researchers there have discovered a way to use thinner materials to generate entangled photon pairs, which could potentially shrink critical quantum computing components by 1,000 times. Imagine taking something the size of a car and reducing it to the size of a matchbox.
That's incredible. So how exactly are they achieving this miniaturization? I mean, what makes these thinner materials so special?
Great question. The researchers are using materials that are just 1.2 micrometers thick, which is about 80 times thinner than a strand of hair. These materials can produce entangled photon pairs without needing bulky optical equipment. It's like having a tiny orchestra playing in perfect harmony without a conductor.
Wow, so it's like they've found a way to simplify the entire setup. But why is this entanglement so important for quantum computing?
Entanglement is crucial because it allows qubits to be in multiple states at once, which is the essence of quantum computing's power. By generating entangled photons more efficiently, we can create more compact and scalable quantum systems. It's like upgrading from a room full of old computers to a sleek, powerful laptop.
That sounds like a game changer. So, does this mean we'll soon have quantum computers that are as small as our smartphones?
Potentially, yes. This breakthrough paves the way for integrating quantum components into chips, making them more practical for everyday use. It could revolutionize industries by providing powerful computing capabilities in a compact form. Imagine having the power of a supercomputer in your pocket.
That's mind-blowing. So what's next for this research? Are there any plans to take this discovery further?
The NTU team is looking to optimize their setup even further. They're exploring ways to increase the number of photon pairs produced and considering stacking these thin materials with others to boost efficiency. It's like they're building the foundation for the next generation of quantum devices.
It's amazing to think about the possibilities. I can't wait to see how this technology evolves and what it means for the future of computing.
Now let's talk about another groundbreaking achievement in the quantum realm. Scientists have managed to maintain a quantum superposition, known as a cat state, for a record-breaking 23 minutes. This is a huge leap forward in quantum stability.
23 minutes? That's like an eternity in the quantum world, right? How did they manage to keep it stable for so long?
Exactly. It's an eternity. Typically, quantum states are incredibly fragile and fleeting. The researchers used advanced techniques to isolate the system from external disturbances, kind of like putting a delicate snowflake in a perfectly controlled environment where it won't melt or be disturbed.
That's fascinating. So what does this mean for the future of quantum devices? Are we looking at more reliable quantum computers?
Absolutely. This level of stability could lead to the development of more robust quantum devices. It means we can perform longer and more complex quantum computations without losing the integrity of the data. Imagine being able to run a marathon instead of just a sprint in the quantum world.
That's a great analogy. And does this stability open up new possibilities for discovering other quantum phenomena?
Yes, it does. With more stable quantum states, scientists can explore new quantum phenomena that were previously too elusive to study. It's like having a telescope that can finally see distant galaxies that were once just blurry spots in the sky.
Wow, so we're not just improving technology, but also expanding our understanding of the universe. It's like quantum physics is giving us a new lens to view reality.
Exactly. It's a new lens that could reveal insights into the fundamental nature of reality itself. This achievement is a testament to the incredible progress being made in quantum research, and it's just the beginning of what we might uncover.
It's truly exciting to think about where this could lead. I can't wait to see what other mysteries of the quantum world will unravel next.
Let's shift gears and explore a truly mind-bending experiment conducted by Imperial College London. They've recreated the famous double-slit experiment, but with a twist. They did it in the dimension of time. It's like taking a classic magic trick and performing it in an entirely new way.
In time, that's wild. How do you even conduct an experiment in the dimension of time? I'm trying to wrap my head around this.
I know, it's a bit of a brain teaser. Instead of using physical slits in space, they manipulated the frequency of light over time using lasers and a special material. Imagine it as changing the color of light with femtosecond precision, creating an interference pattern from different colors interacting with each other.
That's fascinating. So what are the implications of this experiment? Are there practical applications we can look forward to?
Absolutely. This experiment opens up new possibilities in telecommunications, computing, and medical technology. For telecommunications, it could lead to faster and more reliable data transmission by allowing us to control light with greater precision. Imagine internet speeds that make today's broadband look like dial-up.
That sounds like a dream come true. And what about computing? Could this change how we process information?
Yes, indeed. In computing, this could pave the way for optical processors that are faster and more energy efficient than traditional electronic ones. It's like upgrading from a horse-drawn carriage to a high-speed train, drastically improving data processing speeds and reducing energy consumption.
That's a huge leap forward. And how about in the medical field? Could this help with diagnostics or treatments?
In medicine, precisely controlling light in both space and time could lead to advanced imaging tools. This might allow for earlier disease detection or targeted treatments that minimize side effects. Imagine being able to pinpoint and treat cancer cells without harming surrounding tissues.
That's incredible. It's like we're on the brink of a new era in technology and healthcare. The possibilities seem endless.
They really are. This experiment is just the beginning, and it shows how curiosity-driven research can lead to innovations that ripple through multiple fields. We're witnessing the dawn of a new chapter in quantum physics. Now, let's explore how quantum technologies are making waves across various industries. From finance to healthcare and energy, quantum computing, sensing, and communication are set to disrupt and redefine these sectors. It's like watching a wave of innovation sweep across the landscape.
It's amazing to think about. So, how exactly are these quantum technologies being applied in these industries? Can you give some examples?
Certainly. Let's start with healthcare. Quantum-enhanced medical imaging is one area where quantum sensing is making a significant impact. By providing higher-resolution images at lower radiation doses, quantum sensors could revolutionize diagnostics, allowing for earlier detection of diseases like cancer. It's like upgrading from a blurry photo to a high-definition image, revealing details we couldn't see before.
That's a game changer for sure. And what about secure communication? How does quantum technology play a role there?
In the realm of secure communication, quantum key distribution is a standout application. It uses the principles of quantum mechanics to create encryption keys that are virtually impossible to intercept without detection. Imagine having a lock that alerts you the moment someone tries to pick it, ensuring your data remains secure.
That's like having a digital fortress. And how about in the energy sector? Are there quantum technologies making an impact there as well?
Absolutely. Quantum batteries are an exciting development in energy storage. They leverage quantum effects to store and release energy more efficiently, potentially shortening charging times and increasing storage capacity. It's like having a battery that charges in minutes instead of hours, revolutionizing how we manage renewable energy.
That's incredible. So we're looking at faster, more efficient energy solutions. It seems like quantum technologies are touching every aspect of our lives.
Indeed, they are. As these technologies continue to evolve, we're likely to see even more innovative applications across various sectors. It's an exciting time, as quantum advancements promise to reshape industries and create new opportunities for growth and development.
It's truly fascinating to think about the future possibilities. Quantum technologies are opening doors we never even knew existed.
As we wrap up our exploration of quantum technologies, let's shift our focus to a fascinating topic in particle physics, the discovery of the Higgs boson. It's a subject that has sparked much debate about its relevance to everyday life and the importance of trust in scientific processes.
The Higgs boson, often called the God particle, right? I've heard it's crucial for understanding why particles have mass, but how does that affect us in our daily lives?
Exactly. It's a fundamental piece of the puzzle in particle physics. While it might not directly impact our daily routines, the discovery of the Higgs boson enhances our understanding of the universe's fundamental structure. It's like discovering a missing piece of a giant cosmic jigsaw puzzle, helping us see the bigger picture.
That makes sense. But why is there so much debate around its discovery? Is it about the methods used or something else?
The debate often centers around the complexity of the experiments and the rigorous methods required to confirm such a discovery. Particle physics experiments, like those conducted at the Large Hadron Collider, involve massive collaborations and intricate data analysis. It's like conducting a symphony with thousands of musicians, where precision and coordination are key to success.
I can see how that could be challenging. So how do scientists ensure the accuracy of their discoveries in such complex experiments?
Trust in science is built on rigorous processes and peer review. In particle physics, experiments are often replicated by independent teams to verify results. The scientific community relies on transparency, open data, and meticulous analysis to build consensus. It's like having multiple referees in a game, each ensuring the rules are followed and the outcome is fair.
That's reassuring to hear. It sounds like a lot of effort goes into making sure discoveries are accurate and trustworthy.
Absolutely. While the Higgs boson might seem abstract, its discovery underscores the importance of scientific inquiry and the pursuit of knowledge. It reminds us that even the most complex questions can be tackled with perseverance and collaboration.
It's inspiring to think about what science can achieve when we trust the process and work together. The universe still holds so many mysteries, and who knows what we'll discover next.